Good morning, everyone. Today we're going to explore how shadows are formed. Before we begin, I'd like you to look around the classroom. Can you find any shadows?
Yes, I can see the shadow of your desk on the floor.
I can also see my shadow because the sunlight is coming through the window.
Part 1, Questions 1 to 5. Complete the notes below. Write one word only for each answer.
Excellent observations. A shadow is a dark area that forms when an object blocks light from reaching a surface. In other words, light cannot pass through the object, so the area behind it becomes darker. Can anyone think of another example? When I walk outside on a sunny day, I always see my shadow on the ground.
Exactly. Your body blocks the sunlight, so a shadow appears behind you.
Without light, there would be no shadow at all.
Now, what do we call something that produces light?
Is it called a light source?
That's correct.
A light source is anything that gives off light. Natural light sources include the sun and stars. Artificial light sources include flashlights, candles, and light bulbs. Not every object gives off light. For example, the moon only reflects sunlight, so it is not a light source.
Now, let's do a simple experiment.
Here is a flashlight.
A toy block and a white screen.
First, I'll switch on the flashlight.
Can everyone see the light shining on the screen?
Yes.
Now I'll place the toy block between the flashlight and the screen.
What do you notice?
A dark shape appears on the screen.
That's the shadow.
Exactly.
The toy block blocks the light, preventing it from reaching the screen. Notice that we need 3 things for a shadow to form: a light source, an object, and a surface where the shadow appears. If we remove the object, the shadow disappears immediately because the light can reach the screen again.
Part 2, Questions 6 to 10. Choose the correct letter A, B, or C.
Now that we understand how shadows are formed, let's investigate how different materials affect light.
Look at the objects on my table. I have a glass cup, a clear plastic ruler, a wooden block, and a sheet of wax paper.
Do you think they all allow light to pass through in the same way?
I don't think so. The wooden block looks solid.
But the glass is clear.
I can see through the glass, but I can't see through the wooden block.
Exactly. Scientists classify materials into 3 main groups according to how much light they allow to pass through.
The first group is called transparent materials. Transparent means allowing I pass through. So we can big objects literally under us appeared. Common examples include clean glass, clear plastic, and clean water. If you shine a flashlight through a transparent object, very little light is blocked.
As a result, the shadow is usually very faint or may not be visible at all.
Let's try it. Let's try it.
I'll place the glass cup in front of the flashlight.
Can you see the shadow?
I can, but it's very difficult to see. That's because almost all the light passes through the glass. Now let's move on to the second group, translucent materials. These materials allow some light to pass through, but not all of it. Can anyone think of an example? Maybe a thin curtain?
Excellent.
A thin curtain is a good example.
Other examples include wax paper and frosted glass. When you look through these materials, you can tell that something is behind them, but the image is not clear because the light is scattered in many directions.
Let's compare 2 classroom windows. One window has ordinary clear glass.
The other has frosted glass. Which window allows you to see the playground more clearly?
The clear glass.
That's right.
Now let's shine the flashlight through the sheet of wax paper.
Notice the shadow on the screen. It's easier to see, but it's still not very dark.
Exactly. Translucent materials produce faint shadows because they block only part of the light. Now let's look at the third group, opaque materials. Can anyone tell me what opaque means? Does it mean that light cannot pass through the material?
Exactly. Opaque materials block all light.
Since no light passes through them, they create dark, clear shadows.
Part 3, questions 11 to 15. Complete the table below. Write no more than 2 words for each answer.
Now let's go outside for a moment and observe our shadows during the day.
Have you ever noticed that your shadow changes in length? Oh, Hadley.
Yes.
Sometimes it's very long, and sometimes it's quite short.
That's because the position of the sun changes throughout the day.
Early in the morning, the sun is low in the eastern sky.
Because the sunlight reaches us at a low angle, our shadows become long.
As the sun rises higher, the angle of the sunlight changes.
At around noon,
The sun is at its highest point in the sky.
this is when our shadows become the shortest. Later in the afternoon and evening, the sun moves lower toward the western sky.
Once again, reclossus voir, the sunlight reaches us at a lower angles, causing our shadows to grow longer. So the object doesn't change, only the position of the sun changes.
Exactly. The size of the shadow changes because the position of the light source changes.
This is one reason why sundials can tell the time. They use the changing position of a shadow as the sun moves across the sky.
Part 4, question 16 to 20. Choose the correct letter A, B, or C.
We've learned that the position of the sun changes the length of a shadow. Now let's investigate what happens when we use a flashlight instead. On the table, I have a flashlight, a toy cube, and a white screen. First, I'll place the toy cube about 1 meter away from the flashlight. Can everyone see the shadow?
Yes. Now I'd like you to make a prediction.
What do you think will happen if I move the toy cube closer to the flashlight? I think the shadow will become larger because the object blocks more of the light.
I agree. The shadow should also become longer.
Let's find out.
I'll slowly move the toy cube closer to the flashlight. Look carefully at the screen. What do you notice?
The shadow is getting bigger.
It's also becoming longer.
Exactly. When an object is moved closer to the light source, it blocks more light. As a result, the shadow becomes larger and longer. Now let's try the opposite. I'll move the toy cube farther away from the flashlight and closer to the screen. Watch the shadow carefully.
Now it's becoming smaller. And it's much shorter than before.
That's correct.
The farther an object is from the light source, the smaller and shorter its shadow becomes. Scientists use this idea in many fields, including photography, stage lighting, and engineering. Before we finish today's lesson, let's review what we've learned. Shadows are formed when light is blocked by an object. A shadow cannot form without 3 things: a light source, an object, and a surface.
Transparent materials allow most light to pass through. Translucent materials allow some light to pass through.
Opaque materials block all light and produce the darkest shadows. Finally, remember that the size of a shadow depends on the light source and the position of the object.
Understanding these ideas helps scientists and engineers design buildings, cameras, projectors, road lights, and even solar energy systems.
I didn't realize shadows could be so useful in everyday life.
Me neither. Now I understand why shadows change and why different materials produce different kinds of shadows.
Excellent work today. I hope you'll notice shadows everywhere you go and think about the science behind them.